With the introduction of ads in Uber Eats, the engineering team at Uber needed a way to ingest data from two separate sources: events generated by ads and orders made through the app. But if Uber can't link ads to actual orders, they can't understand their impact. That's why the Uber engineering team developed this system. It's designed to ingest data from different sources and find matches between the ad events and the corresponding order. Ad clicks come into Kafka. And are sent to Apache Flink, where the data is aggregated and cleaned. The events are also stored in a Hive data warehouse for later use. Then, each event is tagged with a unique ID. Later in the pipeline, this will be used to remove duplicates, which would otherwise produce incorrect metrics. It's so important that these metrics are correct, because they're served to businesses that depend on them to understand ad performance, to Uber's data science teams to monitor the health of the system, and to Uber's billing system, which is used to charge the business's advertising. If an ad click is attributed to any order any more than exactly once, then the metrics will be incorrect. Doing this is called exactly once semantics, and it's the key technical challenge that this system addresses at scale. The point of this system is to do the complicated task of linking ads to orders and process those events only once to serve accurate metrics. Next, Flink aggregates the events into buckets by minute. A minute is large enough for being reliable, but not too large that it would fill the database too quickly. The aggregated data goes to DocStore, a highly scalable data store. At the same time, the data goes to another Kafka sink. The sink ingests the ad data from the Flink job and data from the businesses serving ads. Here, we have the data which tells us who interacted with what ad. We call this the attributed ad event data. The whole system operates across two regions. Replicas of each component run in each region, and data is balanced between them. This provides a more resilient system, since if one of the regions fail, the other region can still ingest the data. While all this happens, restaurants are receiving orders. The order events are ingested in this system from a Kafka topic, and then matched with the events in DocStore using the user ID. The events generated from the ads have to be attributed to the corresponding order, so the data from these orders are compared with the ad data that was previously sent to DocStore. If there's a match, then we can attribute the order to the ad events, and in that case, the UUID generated earlier is attributed to this order. These attributed orders are sent to a Kafka sink. Then they're merged with the aggregated ad events by a Flink job. This Flink job can also receive information from the other region to improve robustness. This data goes to Hive, so it can be used to derive insights from later. And the data stored in the Pinot database can be used to quickly provide dashboards so users can query different metrics to measure the performance of the business. This impressive data pipeline enables Uber to serve valuable metrics to businesses based on huge amounts of data from totally separated sources, reliably, accurately, and in near real time.